So welcome everybody to SAC304. This is Predictive Security using big data to fortify your defenses. My name is Matt Nguina, and I am a solutions architect with Amazon Web Services. And I'm joined by my colleague, Michael Capicato, also a solutions architect with AWS. We thought we'd start this session off by talking a little bit about some of the headlines that came out of cybersecurity from 2015. The first that we thought was a really interesting one was this idea of over 169 million PII breaches last year. And the really interesting thing here is that they came across a variety of different sectors, including business, education, government, and healthcare. And these are the sectors that we think of as being the most secure and responsible for holding our PII data. Additionally, in 2015, we found that the number of incidents had actually increased by over 38% from 2014. And this was another really interesting statistic, which was around how long an attack remains dormant within an environment. And it was identified to be over 200 days. The other thing that was sort of interesting from companies surveyed related to security stats is that only 38% felt that they were ready to address a sophisticated cyber attack. And perhaps most interestingly of all is that 81% reported that they needed to rely on an external party to notify them of breaches because they didn't have a system or a managed security service in place. And so that's really what the purpose of this presentation is how we can make this better. So in this session, we're going to learn what are the components to make a predictive log analytics stack, utilizing Amazon Elasticsearch service. This is going to give us the ability to create dashboards, enable our operations teams to create queries and get greater insight from our data sets. We're going to be able to leverage the Elasticsearch API to be able to extract individual logs and then use that log data to ingest into Amazon machine learning and allow us to predict bad actors. We're also going to introduce a new tool that allows you to perform network forensics and path identification throughout the AWS networking constructs. And lastly, we're going to talk about implementing additional advanced options on top of your continuous predictive security stack. So where do we start? Well, at AWS, we really think about big data in terms of volume, velocity, and variety. And what better exemplifies big data than logging? You know, most systems and applications today generate logs. They include operating systems, browsers, intrusion detection systems, anti-malware, firewalls. And as security professionals, we've all been ingrained to ensure that we've enabled logging across all of our environments. And we do this because, like the stats are showing, it's very likely that every organization in the world is fielding malicious attacks on a daily basis. Whether that's in the tens or in the thousands, it's crucial for businesses to be acutely aware of what's happening through their systems through active security log review. So why do we start here? Well, the reason is nobody looks at them. And it's generally, and if they do, it's generally in retrospect, after an incident has actually already occurred. The other important aspect of logging is that we can find evidence of precursors to an attack. So to put it in an analogy forward is, if you think about what law enforcement investigates a crime, they do more than look at the specific crime scene. They'll canvass the area. They'll interview individuals who knew the victim. They'll solicit requests to the public for anyone who might have additional information related to the crime. Well, a similar process needs to take place when we're talking about intrusion analysis and log analysis. If your web server is attacked, you need to analyze more than just the web server logs. You need to search through firewall logs, API calls, systems protecting the web server for other activities other than just individual source addresses. Reviewing all this information collectively provides a more complete picture of the incident and assists in answering the 5 W's of an attack: who, when, what, which, and where. So how are we going to do that? Well, we're going to start by building a log analytics stack, because with this stack, we're going to get a single pane of glass that encourages queries, dashboarding, and exploration of our data sets. But we need to populate that data. So what are some of the log sources we can use for correlation in AWS? The first one is AWS CloudTrail. This is something that organizations that you guys are from came to AWS and said, in order to continue to adopt cloud services, we need to be able to answer questions around who interacts with our environment. Those same 5 W's can be applied to who made an API call, when was the API call made, what was the call, which resources were acted upon, and where was the API call made from and to. With CloudTrail, we've actually established some best practices for folks to take back, including things like enabling in every region within an account. So CloudTrail is typically on a per region basis. And while you may have specific regions that you deploy resources to, you want to be aware if resources are spun up in other regions. You also want to turn on things like CloudTrail file validation and encryption to preserve the validity of your logs and ensure that no one is tampering with that data. The next important piece of log data would be our endpoints. We want to collect the OS and application logs. With the CloudWatch Logs agent, we can easily configure logs, or instances to send OS and application logs into CloudWatch Logs so that we have a view from each of our endpoints. Finally, the one we're going to talk about today is VPC flow logs, so capturing traffic flowing throughout your AWS environment. This can be captured on an interface, subnet, or right across the whole VPC. You can also capture on other interfaces for other AWS services, including ELB, RDS, Elasticache, Redshift, and Workspaces, all without having any agents installed. So all this data needs to go somewhere, and that's CloudWatch Logs. Amazon CloudWatch Logs lets you centralize all of your logs, monitor activity, and allows you to create alarms so you can continually scan for events you know might be suspicious. So now that we have our log sources sending data into CloudWatch Logs, we can actually use Lambda to simplify and stream events to the heart of our log analytics service. And that's going to be Amazon Elasticsearch. The Amazon Elasticsearch service makes it easy to deploy, operate, and scale the Elasticsearch in the AWS cloud. You can set up and configure all the resources for your cluster and just simply launch it. You can do the same thing manually on top of EC2, but this service simplifies and automatically detects, replaces failed instances. It deploys the Elasticsearch software, and reduces the overhead associated with self-managed infrastructure. So let's take a look at how we actually do this. OK, so this is what the Amazon Elasticsearch service dashboard looks like. I've already got an Elasticsearch cluster configured and ready to go, but I'll take you through the steps that are necessary to actually set one up. The first thing you need to do is to create a domain. So in this case, we'll talk about reInvent demo. You specify the version of the Elasticsearch service that you'd like to deploy. You're able to specify the number of instances that you want to deploy, including the ability to allocate dedicated masters and enable zone awareness. So very quickly, you can ensure that anything that is deployed is also made aware of availability zones, so that your Elasticsearch service is not affected in the event that you have an issue in an individual availability zone. You're also able to deploy your storage configuration and customize daily snapshots so that you have the ability to roll back. The other thing you can do with Amazon Elasticsearch service is be able to control access through IAM. So we have a number of templates that are available for controlling access to the service. They include allowing or denying access from specific accounts, so you can create an account specifically for logging within your environment. You can also allow access from specified IPs, Or in this case, we're just going to copy an access policy from the cluster that I've already got set up. And we hit next, and that's it. You review the configuration, you hit confirm and create, and from start to finish, that's about 10 minutes to set up that cluster. Now, the next step that we need to do is to be able to create a log group in AWS CloudWatch logs. So what we're going to do is we're going to go ahead and create a log group. So now we have a place to receive our logs. I won't go through all of the various options in terms of having instances logged to this log group or CloudTrail logs, but I will show you what it looks like from a VPC perspective. In your VPC dashboard, you can highlight the VPC you're interested in interacting with and collecting. You can go to Create Flow Log. You can specify the IAM role that you want to be able to push these logs in, and you can see our CloudWatch log group is already there. So at this point now, VPC's logs are actually flowing into the CloudWatch log group. The last thing that we need to do is stream that to our cluster. So what we're going to do is select the CloudWatch log group. We're going to select Stream to Amazon Elasticsearch Service. Then we're going to specify our cluster. And automatically, we're going to associate a Lambda function that understands how to take those logs and ingest them into Elasticsearch. The next step is to specify the type of log format. And this is so that Elasticsearch can create the correct indices and subscription filter pattern. Hit Next. And you're ready to go. And you're left with 3 important links at this point. So we have links to our dashboards, which are the Kibana 3 and Kibana 4 services, as well as an Elasticsearch API endpoint. And this will become critical in the next section. What we'll leverage this for is to actually extract individual logs to mark as precursors of an attack. From a dashboarding perspective, do a little quick update here. The demo gods are not with me. We're going to do something you probably shouldn't do normally. But we're going to make this really simple here. All right, we're going to take a moment to process this. What we need to do now is, because I had that Kibana dashboard locked down to the outside, so this will just take a moment. But when you first click on that link, you're introduced to a basic dashboard. So now you've got a website for interacting with your logs. If you've worked with SIM solutions from partners like Splunk or Sumo Logic, now you know what you're up against, because you've got a query field where you're able to search through your data set, and you're actually able to create customized dashboards. This is going to take longer than I'd like. Well, I tell you what we're going to do is we'll come back to the dashboards just at the end of the second demo. And what I'm going to do is I'm going to pass it over to my colleague, Michael Capicato, to talk about what we can do now once we have this Elasticsearch cluster up, that we've got our operations teams ready to visualize this data and go from there.
Thanks, Matt. So just pretend for a second that demo worked, and you saw these beautiful Kibana dashboards with all of your log sources streaming into them. At this point, you'll probably be pretty happy, right? You've got this super cool dashboard with real-time visualizations of all your logs, and you can alert and filter on certain metrics. So this allows you to protect against any sort of risk scenario that you know about. There's many common ones that you can think of, right? Imagine you see a single IAM user attempting to log in from 20 or 30 different IP addresses in the span of a minute. That's pretty fishy. Sounds pretty fishy to me, so it's something that I might bake into my dashboard to alert on. However, it's not so great for scenarios that we don't already know about. right? These are common scenarios that I just mentioned that we are aware of in advance, but attackers are growing more and more sophisticated every day. And they might know that you're aware of these detect patterns, and they might circumvent them. So what we want to do now is we want to show you how you can predict against attack scenarios that you're not already aware of. And I'm going to introduce this nifty little thing called machine learning. And I promise it's not as scary as it sounds. So Amazon has built this great service that makes it really easy for you to implement machine learning in your environment. It doesn't require you to hire any mad scientists. You don't need any engineers that understand the intricacies of machine learning algorithms. It's a fully managed service. So you click a button and you can deploy these machine learning models. It's easy to use, and it's not just easy to use for developers. It's really easy to use for anyone. And the machine learning technology under the hood is built on Amazon.com's machine learning technology. So this is a proven system that we've tried, we've tested, and we've got great results from. And you can deploy a machine learning model with just a few clicks of a button. I'm going to show you how to do this in a few seconds. But you can think of a model as your own personal crystal ball that can give you predictions and answer questions based on a whole bunch of data that you feed it. Oh, let me flip back there. There's a few types of models. So the first is a binary classification model. A binary classification model allows you to answer a simple yes or no question. So you could say, based on this person's height, their gender, their hair color, and what the weather is outside right now, are they going to order this product off my website? We also have the ability for you to deploy a multi-class classification model. This type of model is an extension of binary classification. So it's going to answer more than one yes or no question. So maybe, is this person going to buy my product? Are they going to pay for expedited shipping? And are they a repeat customer? Something like that. The model we're going to be exploring today is the third model. It's called regression, specifically numerical regression. And this is a model that gives you, rather than a yes or no answer, an actual numerical prediction. So a simple example is, based on the current political climate and the state I live in, how much is my home going to sell for? We're going to be using it in the security sense. So what we're going to do is we're actually going to feed logs into machine learning and say how threatening is this log on a scale of 1 to 100. So once we've got that machine learning model trained, we're going to create a real-time endpoint that we can query. And that's going to allow us to drastically shorten how long it takes for us to become aware of a threat. This can go from weeks or days down to minutes or even seconds. And the first thing we're going to need to do, just like when you get a new dog, is train that model. So we've set up this log analytics stack. Matt showed us how to do that. And using that Elasticsearch API endpoint that Matt pointed out, we're essentially going to pull all of those logs into a Lambda function, and we're going to transform them in two ways. The first way is just simple formatting to bring them into a CSV format so that machine learning can understand it. The second transform is a little bit more technical and a little bit more important, to be honest. What we're going to do is, based on all of our historical logs, we are going to assign a threat score. So I'm sure that many of you have been collecting logs for years and years and years now, and you're aware of, 99% of these logs are very safe. We know that they're legitimate access. So based on some simple heuristics built into that Lambda function, you can mark those logs with a very low threat score. For the logs that you've seen historically when you've encountered a breach, or logs that you're just unaware of where they came from, you're going to mark those with a higher threat score. So to give you an example, maybe you have offices in North America and South America. So when you start seeing logs coming in from other areas of the world where you don't expect, that might raise the threat score a little bit. And when they come in at a time of day that's not normal for you to receive traffic, again, that threat score might go up even further. So once you've basically created this Lambda function to assign a threat score to your historical logs, You're going to transform them and store them in S3. And at that point, you can point machine learning to that CSV file that sits in S3, and you can build a model off of that with just a few clicks of a button. The other thing you can do is set up a Lambda function that runs, whether it's every day, every hour, or once a week, to continually train that machine learning model to make it even better and even more accurate. So I want to show you now what a sample log looks like that we send into machine learning. So you can see at the top we've got the date and time. We've got the AWS region that that log came into. And then we've got very common items here like the source IP address, the protocol it's using, source and destination ports. And in this case, what we've done is we've used a geo-IP database to map that IP address to a physical location in the world. And that's what the last country, region, latitude, longitude, that's where they come from. So in this case, I'm guessing you guys can see by now this log is pretty suspicious because it's originating from British Virgin Islands, and I'm guessing that most of you don't receive too many traffic from that area of the world. So we have marked it with a threat score of 94. If this was an expected log that we knew to be safe, we would mark it with a much lower threat score before feeding it into machine learning. So let's pretend for a second that we've fed in hundreds of thousands of logs, and that's actually on the order of what you need to have an accurate machine learning model. So I'm sure there's many of you with millions or even billions of log records. When we were building out this demo, we found that by using 15 or 20,000 logs, we were getting not very accurate results. It was only when we got up to the hundreds of thousands of logs that our machine learning model started to shine. So once we've trained that machine learning model, what we can do is for all of the new logs that are coming into our system, we can trigger a Lambda function. And that Lambda function can hit the real-time machine learning endpoint and say, hey, machine learning, for this log, tell me how threatening it is on a scale of 1 to 100, basically. And if Lambda gets a response that's above a certain threshold, so maybe above 80 or above 90, it can trigger a notification that sends you a text message or an email or triggers off some sort of automated action within your system, because that log that just came in probably warrants your attention. So I'm going to show you how to build out what I just spoke about now. Yes. All right. So I'm just going to go to the machine learning dashboard to start off. In the machine learning dashboard, you have a few simple options that you can see here, and I can zoom in just so everyone can see that. The first is create a data source, which is the first step in your process. And then the second is to create a machine learning model built off of that data source. So if I click Create Data Source, we can select either S3 or Redshift as a source. And if I just start typing the bucket name, I can point it to a bucket in S3. And I can point it to that CSV file that I've already uploaded. And I can give it a name. So machine learning at this point is reaching into the S3 bucket, just making sure it has access to that file. And now what it's going to do is attempt to define a schema for our data. So at this point, you can select, say, something like the date time is definitely a text field, but something like the AWS region is categorical, right? There's only a limited number of AWS regions, so you can specify categorical there. And you go through each of your rows, or each of your columns, and just tell machine learning what it should expect. And when that's done, you can give it a target. And the target is what machine learning is going to predict. So we're going to select threat here down in the bottom left, because that's the number that we want machine learning to predict. And just like that, we can click Create Data Source. I've already done it, so I'm not going to click it because I don't want to make you wait 10 minutes. And it would go through and create a data source from that. So I've already created one here called Elasticsearch logs. And essentially, this is taking the logs from that API endpoint, from the stack we set up in the first part of the presentation, and we've transformed them, put them in S3, and uploaded them to machine learning. So at this point, I could just click Use Data Source to create a machine learning model. Now, I've already done this again because I want to save you guys the time of watching that happen. So if we go into machine learning model, you can see I've created this model called Threat Predictor. And this is what we're going to query in real time. Now that model will take, based on your data set size, maybe another 5 or 10 or 15 minutes to create. And once it's been created, you can navigate to the dashboard here. You can actually see the evaluation that was performed. So one cool thing that machine learning does is it will set aside up to 30% of your training data, and it will use it, rather than to use it to train the model, it will use it to evaluate the model after it's been trained, just to make sure it's producing accurate results. And if I just dive into that, we can actually see that this machine learning model has a quality score that's better than the baseline performance. So we know that this model is performing well, it's making accurate predictions. And now you have a few options. Now you've got that trained model, so you can start to ask questions of it. And the first way to do that is by generating batch predictions. So this is great for doing things like overnight when you're not immediately concerned with getting a result. But in our case, we're talking about security. We want to know about a threat as soon as possible, not overnight. So we're going to use one of the second two options. You could try real-time predictions out right in the console here. But what I've done is I've enabled a real-time prediction endpoint. And this can be reached via any internet accessible way. In our case, a Lambda function could call this when it gets triggered with that log entry. But I'm actually just going to hit this directly from the CLI. So let me show you that now. So I've got 3 files in this directory. 2 of them are JSON documents, and let me show you what they look like. So this is a safe record, right? It's, let me just highlight a few things. It's going into the Sao Paulo region in Brazil, and the source IP is originating from Brazil. And it's coming in at 9:55 in the morning, and it's a RDP port. So this is a pretty typical session that we'd expect to see. So what I'm guessing is that our machine learning model is going to give a fairly low threat score when we feed it this. On the other hand, we have a slightly more threatening log record, and it's the one I showed you in the PowerPoint slides before. So this is close to midnight, going into the Sao Paulo region, but originating from British Virgin Islands, where we haven't seen a whole lot of traffic from before. So I'm going to take a guess that machine learning will predict a much higher threat score for this. And the third file in this directory is just a simple shell script. Now this is the important part to focus on. So what we're doing here is we're using the AWS CLI to call machine learning, and we're specifying 3 things. The first is the model ID of that model that we just created. The second is the record that we're feeding it to do a prediction on. And the third is the prediction endpoint that it gave us in the console. And it's going to do this for the safe record. And you can see here it's also going to do the same thing for that threatening record. So I'll run that now. So we can see in real time there, we've called the machine learning service, and it's made a prediction of somewhere around 15 for the record, which was safe, which is kind of what we expected. And for the record that was slightly more threatening, we've got a score of 85. So 85 out of 100 is a pretty high number, and that's something that we typically want to alert on and take some sort of action. That could be manual intervention from your security ops team, or it could be an automated action. And this is what we've built so far. We just want to quickly recap because we're talking about a whole lot of stuff. But In the top left, you can see our log analytics stack. So this is the Elasticsearch Amazon Elasticsearch service that's pulling all of those logs out of CloudWatch logs, visualizing them for you in a Kibana dashboard. And then along the bottom, we have that process that we described for training your machine learning model on a daily basis. In the top right, you can see the Lambda function that gets triggered on every new log entry, and the SNS notification that gets kicked off when that prediction is above a certain threshold. So this is really, really close to perfect, but it's not quite perfect, right? Machine learning, as awesome as it sounds, is not going to predict everything. There's still going to be super smart attackers that manage to circumvent your defenses, and at some point, there's going to be a breach in everyone's system. And we have to be prepared for that. So when a breach does occur, we want to know why it occurred and how it occurred. That way we can prevent the same type of thing from happening again. So it's an iterative process that we follow. And typically, this takes place via some sort of forensic analysis, right? And one of the common areas that we explore post-breach is not just logs, but also all of our networking rules to see how did this attacker gain access and what path did they take to gain access. So I want to just paint a quick picture. Many organizations have moved to a model in AWS where they have many VPCs, many AWS accounts, many subnets and security groups and sophisticated networking constructs within each of those accounts. So this is what a simple PCI environment looks like in a single AWS account. And now imagine for a second that we're running this and we decide that environment needs access to our new API account where it's going to query for some form of information. What we might do is enable VPC peering so that those two accounts can communicate with one another. And you can imagine, this is a pretty simple scenario, but in practice, you might have many of these VPCs, many of these peering connections. Now, if I asked all of you, and it's going to flash, you're going to see it, can that instance in the bottom right communicate with that NAT instance in the top left? Most of us have absolutely no idea without spending hours looking at security groups, network ACLs, peering connections, your route tables. All sorts of stuff in AWS can affect that and allow or block that traffic. So to do this type of network forensic analysis would typically take teams hours and days and weeks of effort, and it's a very manual process, which is, of course, not good. So I want to introduce to you a tool that we've been working on at AWS that helps you perform static network analysis and answer questions definitively about your network using formal reasoning. So this tool, it doesn't have a name yet, is available today either as a web service or a CLI that you can spin up within your own account and use privately. And the main purpose of this tool is to answer questions about your network. And it answers them in such a way that no packets are sent. So it's very different than other tools that exist today on the market. The way it works is it essentially creates a snapshot of your entire AWS network. Whether you have one account or 100 AWS accounts and dozens of VPCs within each of them, this tool is going to create a static snapshot of everything that's present in your environment. Security groups, network ACLs, route tables, peering connections, your internet gateways and your virtual private gateways. And once it constructs this snapshot, you'll be able to ask very specific questions, like, can this instance in one account in one VPC talk to this other instance in another account in another VPC? And I want to kind of expand on that, because maybe they can't communicate with each other directly, but maybe there is a series of hops through a bunch of other instances that allows them to communicate with each other. This will also answer those types of questions. So I actually want to show you a quick demo of how this works. There's a simple query language that you can use, and let's see if I can play this. Yeah. Can everyone see that okay? So this is a sample query in this tool that we're discussing here. And it says a few simple things. So the first thing you'll see is the all instances, or all instance. So what we're trying to say here is, for all instances in our entire network that have a tag with Bastion as the value, in other words, all of your Bastion instances, can you SSH from the internet into those Bastion instances? And the arrow in both directions that you see on the second line indicates kind of a two-way relationship. So what this query is saying is it true that all instances tagged Bastion are SSHable from the internet, and vice versa? Is it true that all instances that you own that I can reach from the internet, do they have a tag of Bastion? Right, so when we run this query, we expect to see a result of true, because we know that the only instances that should be reachable from the internet in our account have this tag of Bastion. And if I fast forward to the query getting run, we'll see a result there of false, which means something has gone wrong. So what we're going to do now is we're going to actually deconstruct that query so that we can understand what went wrong. And the first thing we do is we're going to issue another query that you can see here at the top of the screen. This is the first half of the query I just showed you. What we're doing is we're listing every instance in our AWS account that has a tag Bastion. And we can see there's just one instance there. Now what we're going to do is we're going to look at the second part of that query. And the second part of the query is, at the bottom of the screen now, list all of the instances I own that you can reach from the internet, right, that are SSHable from the internet. Now we're hoping that this produces a result of just that instance above, but of course it's not going to. So it's actually produced two results here. So just using a few queries on this tool, what we've done is we're able to uncover that not all of our instances that are reachable from the internet have a tag of Bastion. So what this probably indicates is that someone has inadvertently spun up an instance that is reachable from the internet, and they haven't tagged it appropriately. So this can allow us to go and take some sort of remediation action against that instance. And I guess it's worth calling out at this point that if you're interested in participating in the private beta and testing this tool out, we're going to be at the end of the hall after the presentation. You can come talk to us and give us your contact information, and we'll reach out. So I'm going to hand things back over to Matt now, who is going to talk to you about some advanced options on AWS.
Actually, do you guys mind if we just take a moment and see if this updated? If you guys don't mind flipping back to this. Yeah, here we go. Perfect. So I just wanted to complete the section that we were talking about with respect to the Kibana dashboards. That was that initial viewpoint that you get when you first set up an Elasticsearch cluster. Again, it gives you some initial insight, shows you the logging data is coming in. You've got the ability to query data and start to build graphs that help this data make sense. But we also have the ability to create customized dashboards. So again, for our security operations teams where they want to see what's going on within our environment, we can chart and plot the information going on within our account, as well as take a look at the VPC flow logs. So the information that's actually flowing live within our account, get reads back on the actual data, the top addresses, plot those, and create information that's relevant to our security teams. Perfect. I really love the network reasoning tool that Michael was just showing. Partially for the sort of geek aspect of it. I think the tools that we're creating today to assist in human-computer interaction work really well with something like this, because now our networks, our logs, our machine learning clusters can actually become a member of our team. They're not just something to maintain. We can actually ask them for information. We can get feedback directly from them. But no single tool is ever going to be perfect. So when you return to your organizations next week, we'd like to leave you with some considerations for your defense in-depth strategies. What can we do on top of the log analytics service, the machine learning, the dashboarding that we've created for our DevSecOps teams? The first is to think about how to help evolve your security practice. One of the most compelling issues in security architecture today is the cycle of security standards, configuration drift, audit, and remediation cycles. In a dynamic cloud-based environment, simply setting a static security position isn't enough. We need to encourage more interaction between our development, operations, and security teams. In the 3 tools that we've demonstrated so far, we've included threat modeling, API interactions, high availability requirements, all of those requiring true cross-functional teams. When we move to things like immutable infrastructure, infrastructure as code, we actually open up new ways of securely implementing changes within our environment. We can create CloudFormation templates or other artifacts that define what our environments look like and pull our ops teams away from the data. We don't want manually created instances. We don't want to have instances that don't have correct tagging associated with them. And as well, for our audit teams, we want to have a single point where they can take a look at what our environment looks like at any point in time and not have to crawl through what the current configuration is, because you'll know based on the last time that environment was deployed. But that said, if we're not there today, what are the options available to us? Well, we now have a few more tools in our tool chest. We have self-managed solutions that are available. Things like using CloudTrail, CloudWatch logs, and CloudWatch alerts to automatically notify when changes occur within our environment. We have the ability to take changes within our environment and actually use them in conjunction with our network reasoning tool. So we gave the example of when a new EC2 instance is spun up, does that open up a hole to a secure area of our network? We can ask the network reasoning tool, or we can use the network reasoning tool to actually create snapshots of the environment and give us a time series to compare changes against and understand exactly when this change occurred. For compliance and validation services, we have AWS Config and AWS Config rules. Config was introduced to allow for a time series collection of all the changes within your environment. And config rules was another thing asked for by organizations to be able to run reports and ensure that the instances that were being deployed were actually compliant with the organization's standards. So Michael gave you an example during our network reasoning tool that showed an instance that didn't have the tag bastion associated with it. Well, with AWS config rules, you can ensure that key tags are on each of your instances or that they're flagged or alerted. So when you want to make sure that you know who the owner of a particular instance is, what the cost center for that instance is, or what the escalation point is, it's there. And you have the ability to take automated actions as a result. So if someone deploys an instance and it's not properly tagged, what do we want to do with it? We can put it into a lockdown security group, we can send a notification, or depending upon what your standards are, you can terminate that instance. We have options for host-based compliance validation. So we talked about collecting the logs from what are deployed on the individual instances, but we also want to do things like check what software versions are installed, actually look at the patch levels of the operating system and compare those against CIS benchmarks and report back on the current standings within our environment. And we also have options for active change remediation. So taking those CloudWatch events and taking automated actions for them. On the machine learning side, we've talked about a really simple threat-based model that's based on an individual log entry. You know, the idea of the anomalistic nature of seeing a single entry from a particular IP address. But what are the precursors for attacks within your environment? You really need to train your model with your data. Real-world data specific to your applications and your environments are going to help to create models that are more relevant to your environment. And you really want to consider clusters of logs. So again, the idea, we showed sort of an RDP connection as a single event in and of itself. But imagine that you started to see API calls from a particular IP that included things like list and describe actions. The actions in and of themselves are not harmful, but they may be indicators that somebody is probing within the environment to get a better sense of what you have deployed. So you want to identify threats more accurately than just a single log entry, and build threat profiles that pattern typical attack stages. Now, I talked a little bit about the reconnaissance stage. It's equally important to look at things like the covering track stage. So what are the things that we can put in place within our environment, ensuring that the important pieces of information, intelligence within our environment, CloudTrail, remains turned on. In the event that that gets turned on and a log message to that effect is triggered, we want to take an action on that, either turn it back on, cut an alert. We want to make sure that people can't just tamper within the environments. Tying it all together now, we have our sort of complete predictive and continuous scanning environment here. We have our log analytics stack up in the corner that contains CloudTrail logs, instance, SSH, OS logs, VPC flow logs, all stored into Amazon Elasticsearch. We have a daily Lambda function that ingests this data, massages it, transforms it into the format that machine learning needs, and marks it with threat indicators and stores it in an S3 bucket. We also have the ability to have a Lambda function trigger on each new log entry that comes through. So every time we go through this training process, we improve our predictions a bit more. And we have options to either continue to allow that traffic, flag it, or make changes to security groups that will block it. With the SNS notifications, we have the ability to do things like check when the instance is started, what potential impact that has on the rest of our network. When we introduce that new VPC or that new VPC peering relationship, are we inadvertently introducing additional security paths into our environment? And we also have AWS config rules that allow us to ensure that the standards we put in place continue to be adhered to. So next steps. If you guys are like us and you're really interested in this stuff, we have a blog post up for setting up your own log analytics stack. This includes a CloudFormation template for deploying the ES cluster onto EC2 and contains those dashboards that you saw. We also have a blog post for building your first Amazon machine learning model. These are your first foray, your first steps in there to understand how you might model these threats and attacks. As Michael mentioned, if you're interested in learning more about the network reasoning tool, we're going to be just outside to take any questions or get your contact details if you'd like to help us out with that tool. And stay tuned on the AWS security blog, because we really think there's something interesting here. We think there are more and more Lambda functions that actually show different types of threat modeling. So keep an eye on the AWS security blog for more information. And we're here all week. We love this stuff. We live and breathe security in Amazon every day. So come chat with us. So on behalf of Michael and myself, I'd like to thank you all for coming. And remember to complete your evaluations. Thank you very much.